Okay, so this is Sneaky SAT Algebra Level 2. This is going to be the tougher worksheet. And these problems are very similar to certain problems that you will see on the SAT before they change it in 2016. Before that, the problems should look a lot like this. Okay, so our first problem says if 3x plus 1 times 3x minus 1 equals 2, what is the value of 9x squared? Okay, so this is a spot where it's really beneficial to know about perfect square factoring and how to use it. And the hint here is that these two binomials are kind of the result of a perfect square factoring. And we can kind of see that if we FOIL. So let's FOIL. So 3x times 3x is 9x squared. 3x times minus 1 is minus 3x. 3x times plus 1 is plus 3x. 1 times minus 1 is minus 1. These two cancel as we expect for a perfect square for a difference of squares like this. So that is our original kind of function before it would have been factored. And now we're actually almost there. Remember, our job is to solve for 9x squared. So it's easy to go too far on this one. It's an easy mistake to make. You don't want to solve for x. You just want to solve for 9x squared. So I'm just going to add 1 to both sides. So I get 9x squared equals 3. So the answer must be D. Notice, if I tried to solve that for x, it would have taken much longer. So we are saving time, which is going to help you really kick butt on the SAT. Okay, number 2 says, it says 2y plus z over z is equal to 3 over 2. What is the value of y over z? So we want to figure out if we can pull a y over z out of this somehow, because there's no way to solve this because it's only one equation and it has two variables. And if I ever have more variables, then I have equations I can't solve. So I'm going to have to be sneaky. All right, I noticed right away that I can split this fraction into two parts. Remember, in the numerator, if you have a plus or minus, an addition or a subtraction in the numerator, you can split it into two parts. So I can say that this is equal to 2y over z plus z over z. So I just split it into the two parts and divided each part by z, and that equals 3/2. Just as a quick side note, remember that if I had the reciprocal of this, like this, 2y, oops, I guess I'm going to do it like this, z over 2y plus z, this I can't do the same thing on. I can't split it into z over 2y plus z over z. So this is not allowed, okay? Only when the subtraction or addition problem is in the numerator are you allowed to do that. Okay, so back to here. Here's my equation. And now I see that I have z over z. That's kind of nice. So these are gone. They're toast, okay? And I have 2y over z is equal to 3/2. Okay. So now, let's see here. What am I solving for? Oh, yes, right, so y over z. So remember on these to stay focused. Don't go into math autopilot mode. It's really easy just to get caught up in solving for x, solving for y, because that's your job in math class usually, but it's not your job in the SAT. Your job in the SAT is to follow very specific instructions. And here our instructions are to find y over z, and I see that I already have 2y over z. So, oh, and hold on. Okay, pause for a second though. This is just 1. So this should be 2y over z plus 1 is equal to 3/2. I'm going to write that a little bit neater. So our next step is 2y over z plus 1 equals 3/2, because z over z turned into 1. And now I want to subtract 1 from both sides because I'm trying to isolate y over z. So I get 2y over z equals 1/2. And now how do I get y over z alone? I divide both sides by 2 to make this 2 go away. Okay, so I get y over z. And now what is 1/2 divided by 2? It's 1/4. You can use your calculator if you want. And that is our answer. So y over z is equal to 1/4, which is answer choice D. And that matches my answer key. Great. Okay. Number 3 says, if x minus y squared is equal to 169 and x plus y squared is equal to 81, what is the value of xy? Okay, this is a nice sneaky College Board problem. Solving this explicitly with substitution or elimination or something like that would take a long time. So let's look for a shortcut. First, I'm going to FOIL each expression. So first I see that x minus y squared equals 169. So I'll write x squared minus 2xy minus y squared equals 169. So I foiled that. You can FOIL it out with an extra step if you need to, or you can memorize the formulas from my my one-page guide to this section, which is linked to below. So there we go. And right below that, I'm going to write the other one. So the other equation is x plus y squared, which is going to be x squared plus 2xy plus y squared is equal to 81. Okay, so now we're going to have to get sneaky here. Let's see. Okay, so I'm looking for xy, which is pretty similar to my middle term. Okay, so what I can do to get rid of, well, let me zoom out a little bit here. I'd like to get rid of my x squareds and my y squareds. These are kind of annoying. And I've written this intentionally as kind of an elimination problem. I'll show you what I mean. What I mean is I can subtract this whole equation. Okay, and when I do that, some really nice things happen. These x's cancel. This becomes negative 2xy, which if I add these becomes negative 4xy, which is not exactly what I'm looking for, but it's a whole lot closer than x squared or y squared. What happens here? Oh shoot, I made a mistake. So when I FOILed this should have been a plus. So that's on your formula sheet. And let's see. Yeah, so make sure you're comfortable with that. So it's plus, because minus times minus is a plus. Okay, so now I subtract this and I get 0 again. And now I have 169 minus 81. You may be able to do that in your head, but on your test, I want you to make the best use of your calculator possible. So this is 88. And now I'll divide both sides by negative 4. And I'll get xy equals negative 22. Okay, which is answer choice A. Boom. All right, number 4 says x squared minus y squared equals 30 and x minus y equals 6. What is the value of x? Okay, so I see a perfect square factoring problem, so I'm going to go ahead and jump right in. So remember, x squared minus y squared is going to factor as x minus y times x plus y. If you know that, you're going to save yourself a lot of time. Okay, and I know from the problem that x minus y equals 6. And I see an x minus y here, so I can just substitute. I'll write 6 times x plus y is equal to 30, okay? And I will divide both sides by 6, that's cool. And I'll get x plus y is equal to 5. All right, is that an answer? Oh, it's a free response. I'm gonna say 5. Let's see if it matches the key. This is number 4. It does not. Let's see. Either my key is wrong or I'm wrong. Let's have a look here. I'm leaning towards the key being wrong. X minus y is 6. Oh, I see. So yeah, read carefully, man. So make sure you don't get stuck in autopilot, right? So this says, what is the value of x? So we're not quite done yet. We have x plus y, but we need to solve for x. And maybe you're thinking, well, we still have 2 variables, so that's going to be tough. But remember that earlier equation we have. So we just figured out that x plus y equals 5. And from the problem, we know that x minus y is equal to what? It's equal to 6. So now I can add these equations together to make my y's go away, and I get 2x equals 11. And now x must equal 11 over 2. So in this case, they were asking us to solve for x. And we went all the way and we solved for x equals 11 over 2. That's a tough one. Make sure you remember what they're asking you for. Number 5 says, if b times x minus y is 16 and by equals negative 8, what is the value of bx? So this is not perfect square, but it still kind of falls under this umbrella of sneaky algebra. Okay, we can see that by is equal to negative 8 already, so I'm going to FOIL. bx minus by equals 16. And at some point you might be asking, Stephen, how do you know all these tricks? It's really experience, so that's why we're practicing a lot. If you can't recognize these tricks right away, that's fine. That's what we're here for, right? So we're going to practice these. We're going to come back and look at them again, review the videos, do all that good stuff, and you're going to start to recognize these, I promise. But if you don't recognize them right away, that's fine. Okay, so I have by equals negative 8, And now I see I have a by here, so I can just substitute it right in. So I'll say bx, and I have minus negative 8 equals 16. Remember, minus negative 8 is a big plus sign. And now I will subtract 8 from both sides, and I'll get bx is equal to 8. All right, and that is actually what they're looking for. So the answer is D. Does it match the key? Yes, it does. All right, things we're looking up. Okay, number 6 says, if ab squared equals 16 and b minus a equals 2, then ab cubed minus a squared b squared equals. So this one's gonna look really scary. And if you see a problem that doesn't seem solvable, then start right away seeing if you can find a trick or some kind of shortcut. Remember, on the SAT, all that matters is what bubble you fill in. They're not going to be checking your work. So if you have a clever shortcut, then that is fantastic. They're never going to take off points for a clever shortcut because they don't look at your work. They just grade the bubbles. Okay. So here we go. Notice, this is the thing. So let's say you look at this problem for a second, look for a trend here. If I multiply this by this, what I get is going to look a lot like the answer they want. In fact, it might be exactly what they want. So let's try it. So let's try ab squared times b minus a. Let's just try that and see what happens. So if I FOIL, I get ab cubed minus a squared b squared. And then what do you know? That's exactly what they're looking for. Okay, problem's a lot simpler than it was. And now I know that ab squared is just 16. These are equivalent. B minus a is just 2. So this problem is just really 16 times 2, which is 32. That's it. So the answer is E. Let's see if it matches my key. For number 6, it does. Great. Okay. Number 7 says, if 3x minus z is equal to 4y, so I have 3x minus z is equal to 4y, and 3x plus 2y minus z is equal to 5, what is y? Okay, so this is kind of like problems you would see in math class, but there still should be a little bit of a shortcut. And the reason I know there's a shortcut is we still have more equations than we have variables. So kind of in the strict sense you learned in math class, you can't solve this necessarily. It could have a solution, but it may not have a solution. So E is an option. Be careful with E though. I'd say be wary of E on the math section. Don't be wary of E on the grammar section, but on the math section, be a little bit wary of it. Okay, so let's look for a trick here. I would like to write these kind of in the same order. By that I mean I want to put all the variables on the same side. So I'm going to change this equation a little bit. I'm going to change it to 3x minus 4y minus z equals 0. So all I've done is subtract 4y from both sides, and I've written it basically in alphabetical order. Okay? And now the next equation is 3x plus 2y minus z equals 5. All right, are there any tricks I can use to make my life simpler? Well, it looks like if I subtract this equation from that equation, two things will cancel, which is pretty cool actually. So this cancels, so I get 0. Here I get minus 6y, and these cancel because this is a plus z because it's minus minus. And now I get equals negative 5. If that trick hadn't worked, if only one thing had canceled, this problem would not be solvable and the answer would be E. But because it worked, this problem is solvable, and we're almost there actually. All I'm going to do is divide both sides by negative 6, and I'll get y equals 5/6, because the two minus signs cancel. Okay, is that an answer? It is. It's answer choice C. Let's check the key. Did we get it right? No. Oh. All right, my key says negative 5/6. All right, let's see. Is my key wrong or is the work I just did wrong? Let's look carefully. So this is definitely negative. I don't see how it wouldn't be. And this is negative. I think I'm going to go with the key on this one. I'll try to fix this. If not, then just pay attention here. But yeah, this should be positive 5/6. So the answer should be C, not B, like my key says. Okay, number 8 says, it says 3x minus 2y is equal to 9. And it says, what is the value of 9x squared minus 12xy plus 4y squared? Okay, so this is where your perfect square factoring skills come back into play. So let's try to factor this because it looks like a perfect square, and they are asking us to solve for this. So let's give it a shot. So I think I can factor this as 3x plus, and it must be minus because that middle term is minus, 3x minus 2y, I believe, squared. I can factor it that way. If you have time, give it a shot and make sure it works. I'm pretty confident this works. So it should be 3x minus 2y squared is equal to this. They're equivalent. So if that's true, notice that this is just this squared, and we already know this actually. So this must equal 9 squared, because this is the same as 9. They're equivalent, which equals 81. So there you go. This is one where the shortcut saves you literally 5 minutes, and 5 minutes on an SAT math section is incredibly valuable. Incredibly valuable. Time. That's the name of the game. Oh, did we match my key here? We did. Great. Okay, number 9 says, if b does not equal 0 and 3 over x equals 3 minus b over x minus b, what is the value of x? Okay, this one might not be as sneaky. There might not be a huge shortcut, but that's okay. 3 minus b over x minus b. And they had to say b does not equal 0. We'll see why that's important in a second. But okay, I would like to cross multiply. If I ever have a fraction on each side of the equation, I'm always allowed to cross multiply. Okay, so I have 3 times x minus b is equal to x times 3 minus b. So I just cross multiply. That's all I did. And now I'm going to FOIL. So I'll get 3x minus 3b is equal to 3x minus bx. Okay, and this is kind of a good sign here, I think. My 3x's will cancel. If I subtract 3x from both sides, they are gone. And does that solve all my problems? I'm solving for x. Okay, it might. Let's see here. So if these cancel, I get minus 3b equals minus bx. And I want to solve for x, so I'll divide both sides by negative b. And I'll get x equals, these actually cancel, don't they? And that minus sign cancels, so I just get 3. Okay, there you go. Cool. So x equals 3. And just as a small side note, they have to tell you that b does not equal 0 because we're dividing both sides by b here. And if b was not 0, if b was 0, then this would be impossible. This wouldn't be. You can't divide by 0. So that's why they have to tell you that. Just a small detail. But there you go. Notice this problem does not seem solvable just in math class in general because it has 2 variables, right? Again, there's kind of a trick, which is cross multiplying and solving, and some things cancel out. All right, last problem. Number 10 says, if 2x plus 3y equals 2y, which of the following must equal 4x plus 4y? Okay, so this is definitely going to involve some kind of shortcut because we can't solve for both variables because we only have one equation. We're trying to get to 4x plus 4y. Okay. How can I turn this into 4x plus 4y? Let's see here. Well, I don't want to do anything crazy with the x's. I think I'm going to multiply the whole thing by 2 first to get that 4x in place. There's a few options here, but let's try that. If I multiply this side by 2, the whole side, and this side by 2, I get 4x plus 6y equals 2y. Okay, so we're getting warmer. I have the 4x part, and I want to turn this into a 4y, so how do I do that? I just subtract 2y from both sides. So I get 4x plus 4y is equal to 2y minus 2y is actually 0, so that should be our answer. So it's A. Let's see, on my key I said D, I said 2y. Oh yeah, yep, so hopefully you saw this mistake. 2y times 2 is 4y. There we go. So I need to subtract 2y from both sides here, and I will get 2y. So the answer must be D. Okay, great. So that is SAT Sneaky Algebra Level 2.